Hello all, as usual, let us start with a Blinky LED code on this Arduino Uno Q board, and what we are basically looking at here is a Arduino App Lab, and you can see all the different applications loaded here. And on the left, you see two things. One is My Apps, and the other one is Examples. So My Apps lists all the apps that you have created. Here it is called apps. Basically, it's the code the project you create, and then the example has all the examples related to the Arduino Q board. And then we have something called bricks. We will talk about this later. For now, we will stick to the blink LED. So let us try to open the blink LED here. Once you click on blink LED, okay, you can see the beauty of this particular Arduino App Lab is it opens a .md file which actually describes what is happening. So even for us, when we create YouTube videos, right, we have to create the block diagrams. Even that work on us is eliminated here, where you can see the image here shows the communication between a Linux board and a Arduino sketch. Okay, so this on the right you can think of it as STM32 board, and which has a LED connected. Remember one thing: all the peripherals, major peripherals, which are present in the MCU, like the SPI, I2C, UART, or the GPIOs, LED control, buttons, all these are part of the STM32, and all the displays, USB, cameras are part of this particular Qualcomm part related section. Now, we will be communicating between the Linux part, which is the Qualcomm board, which is QRB2210, and then the STM32 part using a software interface which is called a bridge here. So bridge has those APIs defined, and based on those APIs, the communication happen. Now, as we open this page and read MD happens, on the left, you will have three things here. One is assets. Assets are nothing but the doc assets, where you have the PNG files. Okay, you can add your PNG files, whatever. So readmd has this PNG file, right? It appears here. And then you have something called Python. So the code that we write on the board is in Python, especially for the Linux part. Okay, so we have a .py file, and we are writing a code where we have a loop here, and we are calling a bridge. You can see here bridge.call, and we are actually sending a LED state. Okay, and we are running this loop. Now, if you go to the sketch, this is the actual Arduino sketch which we know, which has the setup and the loop. So one is the Python part, and the other one is the Arduino sketch. So the Python part communicates with the Arduino sketch using the bridge. Now we have called the bridge here using the bridge.call, and we are actually going to connect to the STM32 by beginning the bridge here, bridge.begin, and then bridge.provide is the method which actually accepts the parameters from there. Okay, and we are going to get the set LED state. Okay, now here what we are doing is we are actually in the loop taking this writing this set LED state method, and trying to continuously right, low or high. So this is what we are actually doing in the Arduino case. So two things here, one is Python and the other one is the C code, and both are talking together using the bridge interface. Okay, so for a beginner, this looks something different and also a little complicated. But as we start using this, we will have flexibility of where we are talking from a Linux machine to a normal MCU, especially the STM32 holds the Cipher RTOS. So we are communicating between the Linux and a RTOS. Okay, so we'll describe more on what is happening here. This is a simple code, and once you have the code here, okay, now click on run. Once you click run, the console window opens up. You can see here from the editor, it got switched to console, and the console has launched the app. And on the board, this actually is running the code on the board, and we observe here that the LED is blinking on the board. A very simple blinky LED application. Clear, right? Let's explore more about these in the coming videos. But one thing what you have to see here is, if you want to go back, you can go back and you can use any of the application, and you can see here, in case if you are already running something, you see against these application that the blink LED code is running. Again, you can click back, you can go to the console, and you can use the serial monitor or the Python console to see what is happening here. An easy to use interface, right? Everything built into the App Lab, like it's a version, indirectly a version of Arduino, but in a different format. Okay, and you in this readmd you get to know what is happening, how and the code explanation as well, especially for the example codes, and also it has given a brief explanation of each and every variable, functions, and any import that you are going to do. And you can see here, as we have mentioned, bridge.provide is what invokes the actual functionality and gets the parameters from there. You can see registers the set LED state function to be callable from the Python script. Okay, so you know that in the Python script you are actually having this function called. Okay, this is a brief explanation of Blinky LED. We have just explained a example code. We will do more experimentation, and let us talk more about Arduino Uno Q in the coming videos. Thank you.